this is our AP Chemistry lesson video for Chapter 16. We are still navigating equilibrium. And so this is part 2, and I'm going to cover section 16.3 and 16.4. Okay, so we're going to take a little bit of a break from equilibrium for just a minute, and we're going to go to something y'all all know and love, and that's the pH square. The problem is the pH square is not on the formula sheet for the AP exam. Now all the formulas are on there separately, but they're not in that square format. Okay, so just make sure you know how to do it without looking at an actual pH square. Alright, so let's start with something we've learned before. Autoionization of water, we called it self-ionization in honors. It's when one water molecule donates a proton to another. Okay, so when they bump into each other, one hydrogen will be transferred to the other one. So then you end up with H3O plus and OH minus. And that just naturally happens. Not a lot. Most of water is H2O, but a few of them will constantly be switching into the H3O plus and the OH minus. So if we wanted to write our K value, because water is a pure liquid, it's not written in the K value. So it's just your H3O plus and your OH minus. And there would be nothing on the denominator because the reactants are both liquids. Now remember, H3O plus and H plus are used interchangeably. Okay, so that gives us our formula that at 25 degrees Celsius, Kw, the W just indicates it's water, is H plus times OH minus, and that will always equal 1 times 10 to the negative 14. 1 times 10 to the negative 14 is the Kw for water at 25 degrees Celsius. So if you change temperature, your K value will change. Remember, Ks are based on temperature. So if H plus equals the OH minus, then the solution is neutral. If you have more H plus, it's acidic. If you have more OH minus, it is basic. The value of Kw does not change with concentration. So if I change how much H plus or OH minus, that doesn't change the value of Kw. Temperature can change the value of a K. So in other words, if H plus increases, then OH minus must decrease, and vice versa, because when you multiply them, they have to equal 1 times 10 to the negative 14 at 25 degrees Celsius. Alright, so let's look at our first sample exercise together. So it says calculate the values of H plus and OH minus in a neutral solution at 25 degrees Celsius. So we know that H plus times OH minus must equal 1 times 10 to the negative 14. Well, they told me it's neutral, so I know H plus and OH minus are the same. I don't know them, so I'm just going to put in x squared because it's like x times x. So that's 1 times 10 to the negative 14, so of course I square root it. So x is 1 times 10 to the negative 7. Now whenever you solve for H plus or OH minus, remember it's in brackets, so that means you do need a unit, and it's molarity for concentration. Okay, a lot of times because K values actually don't have units, sometimes y'all will start dropping the units. So don't drop them. If you solve for concentration, you need that unit of molarity. Alright, so let's look at the next one. Will you look at the next one? Okay, so I will assume you've paused it and tried it, and then we'll look at it together. I'm not going to pause. I don't want this video to be any longer than it has to be. So it says, indicate whether solutions with each of the following ion concentrations are neutral, acidic, or basic. Okay, so we just decided when it's neutral, they're both 1 times 10 to the negative 7. So all I need to do is compare it to that. Okay, so H plus is 10 to the negative 9 here. When it's neutral, it's 10 to the negative 7. So do I have more H plus or less H plus? I have less H plus, which means more OH minus. Because remember, if one goes up, the other goes down, and vice versa. So if I have less H plus, I have more OH minus. OH minus indicates it is basic. Okay, so that's all you have to do is just compare it to neutral. So here it says OH minus is 10 to the negative 7. Well, that obviously means it's neutral. Alright, and then here it says OH minus is 7 times 10 to the negative 13. Well, this is what OH minus is if it's neutral. So 10 to the negative 13 is less than 10 to the negative 7. So that means it has less OH minus, which means more H plus. H plus indicates an acid, so it is acidic. Alright, so hopefully you got those right. Now if all else fails, what you could have done if you remember your pH squared is done negative log and gotten pH, and then you could have told, or negative log of these and gotten pOH. And then you could have used those scales if you have trouble. But otherwise, you just compare it to what it would be in a neutral solution, which is 1 times 10 to the negative 7. 7 molar. All right, so let's keep going. Oh, there we go. For some reason my clicker decided to stop working. All right, so next sample exercise. So I got this one. So it says calculate the concentration of H plus in a solution in which OH minus is 0.01 molar. Okay, so y'all, we are not going to sit there and keep rearranging the formulas. Okay, you know the formula is H plus times OH minus equals 1 times 10 to the negative 14. So I'm just going to put up the formula and plug in all at the same time. We don't have time for basic algebra here. All right, so we're looking for H plus. So it's 1 times 10 to the negative 14 divided by OH minus, which is, whoops, I don't really need parentheses, 0.01 molar, just like that. All right, and so then when I solved, I ended up getting 1 times 10 to the negative 12. Because I am solving for a concentration, I need molarity as my unit. Okay, and that's it. All right, so here we'll look at this one. It says calculate H plus in a solution where OH minus is 1.8 times 10 to the negative 9 molar. Okay, well, same formula. H plus is 1 times 10 to the negative 14 over my OH minus, which is 1.8 times 10 to the negative 9. And remember, the way that many of y'all type it in the calculator, if you divide by 10 power, then you want to put it in parentheses. Okay, and so when I solved, I ended up getting 5.56 times 10 to the negative 6. And because I was solving for concentration, I put molarity. All right? So like I said, y'all, boy, why can't the whole AP exam be this? Just kidding, because then everybody would make 5s, which really means nobody makes 5s. Alright, so y'all try these. I'll assume you've done it. Get ready to try a bunch today, y'all. There's a lot of practice exercises. I'll assume you've tried it and we'll look at it together. Alright, so it says calculate the concentration of OH minus in the following solutions. Okay, so this time I'm looking for OH minus. So when I rearrange, I get 1 times 10 to the negative 14 over H plus, which in this case is 2 times 10 to the negative 6. Okay, don't forget to put that bottom number in parentheses based on how you type it in the calculator. And so I ended up getting 5 times 10 to the negative 9. And I am solving for concentration, so I put my molarity. All right. Part B should have been super easy. We literally just calculated this a minute ago. Well, what are they when they're equal? Well, they're 1 times 10 to the negative 7. But I mean, I'll show you again how to do it in case you missed it the first time. So H plus times OH minus, of course, is going to be 1 times 10 to the negative 14. I don't know either of them, so I would just call them both x, so it ends up being x squared. And then I square root, so both of them would be 1 times 10 to the negative 7. Don't forget your unit. Okay, make sure you have that molarity. All right, so hopefully you got that one right. All right, the last one's kind of weird. I personally don't like this kind as much. Like, I just want you to give me numbers, let me plug in, get an answer, and move on with my life. But, you know, they didn't this time. So they said, what happens if H plus equals 100 times OH minus? Okay, so what I did here was I plugged in. So for H, I plugged in X, like I'm just using this formula right here. And then for OH, I plugged in 100X because it said it's 100 OH minus. And then I set that equal to 1 times 10 to the negative 14. Okay, so in other words, that ended up being 100x squared, so I divided this side by 100 and square rooted it. And so I ended up getting that x is 1 times 10 to the negative 8. And don't forget that unit, molarity. Alright, so hopefully that one wasn't too bad. So let's move on. So next section is pH squared. pH scale, which is still based on the pH squared. That's where I was headed with that. So if you want to go from H plus to pH, just remember it's negative log of H plus. So that formula will be on your formula sheet. You just got to remember when to use it. pH has no units, just like POH has no units. As pH decreases, your H plus increases. And then a change in H plus by a factor of 10 causes a change in pH of 1. Okay, so if I increase concentration by 10 times of H plus, that will increase pH by 1 unit. So it might go from 2 to 3, or 4.5 to 5.5. So an increase of 100 times would change the pH by a factor of 2. I meant by like 2 units. All right, Alright, so it says calculate the pH values for a solution in which OH minus is 0.01 molar. Okay, so yeah, you have multiple options. You could solve for H plus first and then do negative log to get pH, or you could do the way I prefer, because if y'all use the 1 times 10 to the negative 14, you're more likely to put it in the calculator wrong. So what I prefer is just to do POH first. Oh wait, hang on, let me see what I did on my paper first, because otherwise I won't have the intermediate step. Okay, just kidding. We'll do it the first way, because that's what I did on my paper. I don't prefer y'all to do this way just because I get worried you're going to type in the calculator wrong. But that's okay. We'll follow what I got on my paper. So we know that H plus is 1 times 10 to the negative 14 divided by my OH minus, which is 0.01. So once I do that, I get 1 times 10 to the negative 12 molar. So I need to get the pH. Well, pH is negative log of the 1 times 10 to the negative 12 molar. And so once I plug that in, I got 12.00. And remember, pH has no units. No units on pH. And obviously you could just put 12. That's fine. All right, it's just common practice to give 2 decimal places with pH. I know it's not a significant figures thing. It's just the most common thing that you see. So you'll see me go out 2 decimal places. Now if I was on the AP exam though, I would follow significant figures. All right, so let's look at this one. So it says a solution in which OH minus is 1.8 times 10 to the negative 9 molar. So again, first I'm going to get H plus. And if you're familiar with the pH square, like I said, you could do negative log of this first and get POH, and then do 14 minus. That's the way I actually prefer to do it. So I'm not really sure why I did it this way when I was working these out. I guess because we haven't talked about that formula yet in these notes. Although I know we've talked about it in honors though. Alright, so once I get my H plus, I got that it was 5.56 times 10 to the negative 6 molar. So then to get my pH, I just do negative log of the 5.56 times 10 to the negative 6. And that ended up giving me 5.26. And again, no units in pH. Alright, H plus and OH minus have molarity. pH and POH have no units. Alright, so let me let you try a couple. Like I said, there's lots of practice on this set, so you should be really good at the pH square. Alright, so y'all try these. I'll assume you've done that. Now we'll look at them together. So it says in a sample of lemon juice, H plus is 3.8 times 10 to the negative 4 molar. What is the pH? So yeah, you just plug in. So pH is negative log of H plus, which they told me is 3.8 times 10 to the negative 4. Doesn't get any easier than this, especially when you can use a calculator. Alright, and so I solved and got 3.42. No units. So hopefully you got the same thing. Alright, down here it says we have a commonly available window cleaning solution, has a concentration of OH minus of 1.9 times 10 to the negative 6. What is the pH? So this is where you have to be careful. I got to do this in one step because they gave me H plus, and so I could easily get to pH. But here I need to change OH minus to H plus first, then I can get to pH. Okay, so you always got to be careful of what you're actually given. Alright, so H plus is 1 times 10 to the negative 14 divided by my OH minus, which is 1.9 times 10 to the negative 6. And so once I solve for that, I got 5.26 times 10 to the negative 9 molar. And so now I can plug into that pH formula. And so once I solved, I ended up getting 8.28. No units for pH. Okay, so hopefully you got both of those right. You should have, because we've done this before. We do this in regular. Okay, so you really should have gotten it right. I don't know what's happening with that slide right there. So obviously my answer's already here. I don't know how to get it to go away. So we'll just pretend like we can't see the answer yet, and we'll look at 16.7 together. Alright, so it says a sample of freshly pressed apple juice has a pH of 3.76. Calculate H plus. So if you remember from the pH square, H plus is 10 raised to the negative pH. It's not 10 minus pH. It's 10 like to the power of the negative pH. So I just do 10 to the negative 3.76. Plug that into my calculator. I don't know why I'm going to look at my paper. Obviously the answer's right here. But I got 1.74 times 10 to the negative 4. And then don't forget units. Okay, okay? Even though I didn't give you a unit, I didn't give you a unit because I gave you pH, which has no units. If you solve for H plus or OH minus concentration, you need the unit of concentration, which is molarity. So just be careful of that, okay? If you have me, you know that I super, super, super care about units, and I'm never going to not notice if you leave one off. All right, so y'all try this one. I'll assume you paused it and tried it, and we'll look at it together. So it says a solution formed by dissolving an antacid tablet has a pH of 9.18. Calculate H plus. Okay, so if I want my H plus, I just do 10 to the negative pH, or 10 to the negative 9.18. And when I did that, I got 6.61 times 10 to the negative 10. And then don't forget that molarity. Don't forget that unit. All right, so hopefully this was nice to backtrack to that pH square. So like I said, y'all, the important thing to remember is that these formulas are on the formula sheet, but they're just not in the square form. Okay, so we can also go between OH minus and POH using the same formula. So pH is negative log of H plus. So POH is negative log of OH minus. The POH scale is backwards from pH, so they're both 7 is neutral. But for pH, less than 7 is acidic, more than 7 is basic. For POH, more than 7 is acidic, less than 7 is basic. So you always have to pay attention to what scale you're on. And then if you look, 10 and 4, 5 and 9, 2 and 12, they always equal 14. So pH plus POH always equals 14. So if you know one of them, just do 14 minus it to get the other one. All right, and then indicators are chemicals that change color as pH changes. Each indicator has its own pH range. Okay, so like for example, this methyl red, it goes red, it passes through orange and then turns yellow, and you can kind of see the pH range that that's happening in. Whereas on the other hand, phenolphthalein, it goes from clear to pink. There's no like intermediate color like that since one of them is clear, and it changes at a different scale. It kind of changes right kind of around this 8 to 10 area actually. It goes like clear from 0 until it hits about 8, and that's when it'll switch over to pink. And so that is it. So hopefully, like I said, the pH square was fun to kind of review back over. But just know, equilibrium's going to rear its ugly head in here in the next couple of videos. So, you know, you got this. We can do this.